Hello everyone, my name is Nathan Chi. I'm a software engineering intern here at TwelveLabs, and today I'm super excited to be presenting this brand new project made in collaboration with Voxel 51, that being a semantic dataset curator. So essentially what this project is utilizing both TwelveLabs' powerful video understanding models and Voxel 51's powerful data visualization platform to allow programmers to very quickly build high quality training data sets for their videos. And so this is a super important use case, especially now that a lot of AI models and deep learning rely on not only just training with text, but also with multi-modality features like video and audio input. And so essentially you can see a GIF of this project in the GitHub repository that I've linked in the description. But essentially you can see how with Voxel 51's data visualization platform, you can actually look at the video that you're embedding and then also visualize the embeddings and the specific clusters within your video data. So that can be very powerful for just identifying trends within your data, but then also, of course, for actually building a data set autonomously that you can later use for training your own deep learning model. And then so inside this GitHub repository contains, first and foremost, the code. This code can be accessed in various different ways. We have a full cloud version in Google Colab, and you can access that by clicking this button here. We of course have the local code, which you can access by pulling the GitHub repository. More instructions on exactly how to pull that GitHub repository will be here in the quick start tab of the GitHub repository. It'll go over all the configurations that you'll need in order to get started. And cool, so with that said, that is essentially the project that I'll be going over today. And so to get started, I'll just jump straight into the code within Google Colab. Again, you don't have to do this on Google Colab. If you have like a local data set, it would actually be more preferable to possibly pull that code repository onto your local device and then configure it from there for your use case. And then so yeah, essentially here in this Google Colab, I've already ran all the code cells just because it is a very lengthy end-to-end workflow. So I'll mainly just be describing how it all works. So first and foremost, of course, setting up dependencies. So we install FiftyOne, TwelveLabs, and PyTorch mainly. And then so you'll see how TwelveLabs utilizes those video understanding models to generate that embedding and generate those labels. FiftyOne to actually visualize those embeddings and that data, and then PyTorch for exporting that data set finally. And then so once we have that installed, you'll go ahead and configure your software utilizing your own TwelveLabs API key. And so if you've never used a TwelveLabs platform before, that is completely okay. You can create a free API key here in the playground. Yep, and so you'll have to obviously create your account, but that should be a fairly quick process. And then so for our use case, this you can obviously use this with any video data set you have, either on Hugging Face or just on your local device. But in this case, we had a big focus on worker safety. And then so essentially the sample data set that we'll be using is Voxel 51's safe and unsafe behavior data set. And so again, another reason why I recommend running this on the cloud is because this is quite a large video data set. I believe it contains around 630 videos, and around 10 gigabytes of disk space will be required for this. So if you don't have that disk space, no worries, feel free to just run it here on Colab. And so you can see here, I've downloaded that data set, and it should be located within my file system in Google Colab. And then from here, we load in that data from the files into a 51 dataset object. And then so I won't go too into the technicals of how exactly this works. I would highly recommend you to actually check out their documentation, but at a very high level, this is what this code snippet is doing. And then from there, we also have to initialize a TwelveLabs index. So essentially what a TwelveLabs index is it's a custom collection of videos that gives your videos access to these powerful models like Pegasus and Marengo 3.0. And for those who don't know, Marengo 3.0 is our vector embedding model, and Pegasus is our video to text model. And then so you first have to load your videos into one of these indexes. Just as an example here, you can see I have quite a few indexes already located within my personal account. And then yeah, so essentially we have a lot of these helper functions already built in. For example, get 12labs index. It already calls the native Python SDK to verify if that index is already created, or if not, it goes ahead and creates that index for you, giving it access to both Marengo 3.0 and Pegasus 1.2. And then from there, we go into indexing your local files into the 12labs index. And then so this is done with this helper function, index video to 12labs. And then, yeah. And then so now you can, now that you have those videos uploaded to 12labs, which you can see here, I have one in this index right here. You can see all my different videos that I've uploaded. We then use FiftyOne or Voxel 51's platform to then actually parse through this video data and the specific labels. So of course, again, feel free to read the documentation and read all these amazing comments up at the top to learn more about exactly what each comment is doing. But essentially here, what this code is doing here, base_view, is it's taking that data set that we've downloaded and it's essentially splitting it into this specific train data set. So we want to work with the training data first. As we're building the training data set to export with PyTorch at the end, we want to make sure that the metadata.duration is above at least 4 seconds. And then that the 12labs video ID exists to just ensure that the video hasn't already been indexed. And then here down below, we're calling index video to 12labs to then upload that to our index via our 12labs API key. And so you can see here the labels and the respective videos uploaded and their video ID. So authorized intervention, carrying overload, closed panel cover, open panel cover, all these different videos. So obviously in a real video database, you might not have these labels, but this is just because this is our training data set. And so you don't necessarily need to have these labels. This is just for demonstration purposes to show that we're loading in videos of different types and labels. Okay, cool. And then from there, we are using 12labs Marengo 3.0, which is our latest embedding model, to then actually retrieve these embeddings, the specific float, from our 12labs index that we just uploaded to. And then that's essentially what this code block is doing. You can see fetching embeddings for 24 videos. It shows the time elapsed, and then store 24 embeddings on the data set. And then so the data set here is not just simply an array or a dictionary. Rather, it's FiftyOne's very powerful dataset object that you'll then later see exactly how it's used. But essentially, it's really cool in the sense that these embeddings that we're storing right now will then be translated over into their very advanced web application so that we can actually visualize the clusters generated. And then so, yeah, and so this part is really important as it really shows how powerful and how autonomously actually annotating a video can be nowadays with the power of a foundational video understanding model like Marengo 3.0. We didn't need any human auditor or industry experts. Rather, we relied on 12labs Marengo 3.0 to actually generate that embedding for us that fully understands what is going on within that video and gives it an appropriate vector embedding to later then be clustered. And then so we see here that each 12labs embedding is 512 numbers. And then here we have our cluster labeling prompt. So this is where 12labs Pegasus comes in. So our video to text model, we then autonomously generate the labels based off of the clusters. So again, this goes back to the point I mentioned. If you have a large video database, you typically won't have these labels, which is why you would need 12labs Pegasus to actually then label all these different clusters for you. And so we have an example prompt, which you can of course change for your use case. In this case, we're using workplace safety. So you can see we categorize things like unsafe behaviors and safe behaviors. And then yeah, so we're simply generating the label for each cluster. So safe walkway, safe carrying, authorized intervention, etc. And then from there, we're simply setting these values into our 51 data set. So you can see safe walkway violation. And then this is the really cool part, is the actual visualization of the data. So I might have to reload this, but you can see here, it's a really interactive web application. This might take a little bit longer to load, as it does take Google Colab a while to load these web applications, but you can see it really quickly. You can very quickly visualize your entire data set utilizing the 51 platform. And then from there, you can then instantly see the TwelveLabs embeddings we've generated within this embeddings tab. So this is where that sort of joint workflow comes in, as having TwelveLabs Marengo 3.0 and Pegasus is really cool and foundational to actually building this data set. It's really hard to validate and understand what's going on behind the scenes without a data visualization platform like FiftyOne. And then so here you can see, you can scroll out, you can circle and highlight specific clusters, but you can see the labels that we generated as well, and how powerful the actual Marengo 3.0 model is with actually generating this. And then so lastly, we just have a quick class to actually export this PyTorch dataset. I won't go too much into the details of this class, as it's just pretty much standard implementation on exporting a PyTorch dataset. But yeah, that is essentially the project in its entirety. So although you may not have realized it, you've just seen a complete end-to-end workflow of not only TwelveLabs 2 Premier models, but you've also seen how it works directly with other platforms like Voxel 51. And one last thing before we close out the video, you can of course take a look more at the GitHub and view the architecture if you want to learn more. But we also have a built-in plugin into the 51 app that you can use here. So I know it is a little small, but essentially within the 51 app, you can actually already access TwelveLabs models. Though it won't have as many capabilities as shown here, as we did make a lot of helper functions to sort of assist the implementation of TwelveLabs into the Voxel 51 platform. This provides a lot of handy features, such as creating embeddings, creating an index, and searching the index as well. So feel free to check out both repositories. Both will be linked down in the description. And with that being said, thank you for watching.